Critical points and local extrema part 2. In the last video, we did the concept behind critical points and local extrema. In this video, we're going to do just a few problems to help solidify the idea. So let's find and justify the local extrema of f of x. In the first example, f of x equals x cubed over 3 minus x squared minus 3x plus 2. A reminder, a local maximum is when f prime is 0 or undefined, my shorthand for undefined, and f prime does what? Well, changes from positive to negative. And I will use the shorthand introduced in the last video. Why is this a local max? Well, if f prime is 0, so momentarily flat, that is, f is momentarily flat, and then f is increasing and then decreasing, f prime is positive and negative, of course there's a maximum. A local minimum is when f prime equals 0 or is undefined, and f prime changes how? Well, from negative to positive. Of course, because if f prime is 0 or undefined, we'll do 0, then f is momentarily flat. And if f prime changes from negative to positive, meaning f is changing from decreasing, going down, to increasing, going up, of course there's a local minimum there. Let's do the work now. Remember that we're going to pick out our keyword or phrase, our calculus keyword or phrase. Local extrema always means f prime is 0 or undefined. Since we have a polynomial, we do not need to worry about f prime being undefined, only when f prime is 0. So taking the derivative, we get x squared minus 2x minus 3, and we set it equal to 0. Then we will factor this out, if possible, and it certainly looks like it factors. We get x minus 3 and then x plus 1 as our factors. And local extrema says we need to do the following, our first derivative test. We found where f prime is 0. Now we need to see how f prime changes. I will build a sign chart off my number line, putting my critical points, x equals -1 and x equals 3, in order. Then we will plug values on each interval. I'll start with, say, x equals -2, and plug into my derivative. If I plug in -2 into the first factor, we get negative. Into the second factor, we get negative. Negative times negative is positive. So any x value on that interval will give a positive value for f prime, because f prime will only change at my critical points, -1 and 3. Choosing any value between -1 and 3, that is my next interval, I will choose x equals 0. Plugging in to f prime into the factors, I get negative times positive or negative. Any x value greater than 3, my final interval, I will choose 4. Plugging into f prime into the factors, I get positive times positive, which gives us positive. And then I'll put f up here just because I like to see it. If f prime is positive, f is increasing. F prime negative, f is decreasing. And then f is increasing again. And notice I see my local extrema pretty clearly. There is a local max, that'll be our abbreviation, a local max, at x equals -1. Why? Because f prime is 0, and f prime changes from positive to negative. And there is a local min, min being our abbreviation for minimum, at x equals 3. How do we know? Because f prime is 0, and f prime changes from negative to positive. Let's take a look at our next problem. We're still going to find the local extrema, maxes and mins, which says we need to take our derivative. Right? Keyword of phrase, anytime you see local max, min, extrema, extremum, any of these things, they're all telling you take a derivative and then go on from there. So if I take the derivative, I get 1 and then minus 2x to the negative 1/3. Or 1 minus 2 over x to the 1/3. And let's set that equal to 0. We will solve that. I will get 1 equals 2 over x to the 1/3 by moving this term to the right. Then I will multiply both sides by x to the 1/3, giving me x to the 1/3 equals 2. And then cubing both sides, we get x equals 8. So we have our critical point, x equals 8. Except that I intentionally made a mistake, or really left off something. Students get so much in the habit of finding when f prime equals 0, they sometimes forget to check, is f prime undefined anywhere? And it is. We see that since f prime of x equals 1 minus 2 over x to the 1/3, that f prime is undefined at x equals 0. And since f is defined, f of 0 does have a value, then x equals 0 is also one of our critical points. So let's build our number line here with f prime, and then in order we have our critical points of 0 and 8. And we need to plug in values into our derivative and see what happens. So I'll plug in, say, x equals negative 1. Let me work this one out. F prime of negative 1 is 1 minus 2 over the cube root of negative 1, which is negative 1. Notice that equals 3. The only thing I really care about is that it is positive. So I'll put a positive down in my sign chart. At x equals 1, that is any value between 0 and 8, I get f prime of 1 is 1 minus 2, which is negative. And then some value bigger than 8, let's say, let's do x equals 27. Because I know the cube root of 27, I can do f prime of 27 is 1 minus 2 over the cube root of 27, which is 3. And notice that we get positive. So filling in f, I get increasing, decreasing, then increasing again. And what does that tell us? Well, x equals 0 is a local max. Why? Because f prime is what? Undefined and changes positive to negative. I'll do really abbreviated work for us. And then at x equals 8, there is a local minimum. Why is that? Well, because f prime in this case equals 0, and f prime changes, ch, from negative to positive. So we found our critical points and justified them. Let's take a look at one more example. Let's consider the graph. And notice that this graph is a graph of f prime of x. I would like you to stop the video, just briefly, and in your own mind, determine where does f have a local max, and it might be more than one. And then why you think so, and then determine where f has a local min, and it might be more than one. Where do you think this occurs, and why do you think so? Hopefully you have come back and you have an answer. And my claim is, well, you know what I'm going to do? I'm going to work this one backwards. I'm going to take my keyword of phrase, which says, where does f have a local max? Well, that's always when f prime equals 0, or undefined, which I don't need to worry about in this problem, where f prime is 0 and changes how, right? Well, it changes from positive to negative. That's always true. How about a local min of f? Was when f prime is 0, or undefined, and f prime changes from negative to positive. That's always true. So I'm starting with the underlying truth, and then I'm working backwards. This is what I need. How do I find it? Well, let's look where f prime is 0. I know f prime is 0 right here, and right here. Those are the critical points of f, the only place where f can have local extrema. At this first one, notice that f prime is positive than negative because I have a graph of f prime. So at x equals negative 2, there's a local maximum of f, which I can't see. At my next critical point at x equals 1, notice that f prime, I have the graph, is below the axis, it's negative, and then f prime is positive, so there's a local min at x equals 1. And looking at my final critical point, where I see that f prime changes from positive to negative, that means there is a local max there at x equals 4.